Hello everyone, welcome to my YouTube channel. In today's session, I'm going to discuss about paper 43, May June 2023. This is IGCSE paper. Let's start from the question number 1. Now, before going to the question which are given in the question number 1, let me tell you about the type of the reactions happening here. H positive plus OH negative, which will give H2O. This is the neutralization equation, ionic equation of neutralization. This is ionic equation of neutralization. This is the precipitation reaction because most of the hydroxides are insoluble except ammonium, group 1, strontium and barium. So this is the oxide of chromium. So this is a precipitation reaction. A methane plus chlorine, chloromethane plus hydrogen chloride. This happens in the presence of UV light, and this is substitution reaction. Propene plus bromine, 1,2-dibromopropane, and this is addition reaction. Alkenes always show the addition reaction in which you will get the single product. When a compound is broken down into alkenes and alkane, this is cracking. F is the chlorine plus aqueous potassium bromide. Chlorine is above in group 7 than bromine. So chlorine can displace bromine from its aqueous solution. So this is displacement reaction. Methane plus oxygen. This is a combustion of methane. But as the carbon monoxide is the product, so that's why this is incomplete combustion. Because in complete combustion, when you have excess oxygen, you will always get carbon dioxide as you are getting the carbon monoxide. So this is incomplete combustion of methane. Carboxylic acid, alcohol react to form ester. This is esterification or the formation of esters. Hydrogen plus oxygen to give water. This happens in the fuel cell in which the hydrogen is used as a fuel. Carbon dioxide reacts with the water to make glucose plus oxygen. This reaction shows the photosynthesis. So before answering the different parts of the question number 1, learn the type of the reaction, which is in your specification, and then you will be able to answer each and every question, which is the part of this question number 1. Now, this question says that each equation will be used once, more than once, or not at all. I have already explained all the reaction types. Now, photosynthesis is the J. Addition reaction is the D. Then precipitation reaction is B. Incomplete combustion is G. And the displacement reaction is F. And the substitution reaction is C. I have already given you the idea about the type of every reaction. So just remember all the types of the reaction and then try to complete all the parts of the group question number 1. Then come to the next question. So the symbols of the elements of the period 3 of the periodic table are shown. So these are some symbols of the period 3 elements. The same is the type of the question that each symbol may be used once, more than once, or not at all. Is present in purified bauxite. Bauxite is the ore of aluminium. And that is the aluminium oxide. So aluminium is present in aluminium oxide, so that's why aluminium is the answer. This is present in bauxite. contains atoms with the full outer shell of electron. Full outer shell of electron mean group 8 element. Just look at the periodic table, or you can see that the element which is on extreme right of the periodic table, they are the noble gases, group 8 elements, so argon is the answer. Is used to kill microbes in water treatment. This is the property of the chlorine gas. Chlorine gas, when it dissolves, it provides an acidic medium, and it is used to kill all pathogenic bacteria. So chlorine is the element. Form an amphoteric oxide. Amphoteric oxide has the properties of both acid and base. It has the properties of both acid and base, so that's why aluminium oxide is the amphoteric oxide. There are some other amphoteric oxides as well, although they are not in period 3, but zinc oxide and lead oxide, they're also the amphoteric oxides. Form an oxide which causes acid rain. There are two substances which are responsible for the acid rain, sulfur dioxide and nitrogen dioxide. So in this list, you can see that these are the elements of period 3, but the nitrogen is in period 2, so that's why the answer is sulfur. Has an oxidation number of -1 when it forms a compound with hydrogen. Generally, the elements in group 1, they have their +1 oxidation number, then +2, then +3, then +4. Phosphorus and sulfur, they may have the different oxidation numbers. Sometimes they have +3, sometimes they have +5. Sulfur mostly it may have -2 or +4, then +6, different oxidation states. With chlorine, it has -1 oxidation state, although it may have some different oxidation state, but with hydrogen, hydrogen is positive, so chlorine is -1, so chlorine is the answer. Okay, so the relative atomic masses of elements can be calculated from the relative masses of the isotopes and their percentage abundances. Identify the isotope to which all the relative masses are compared. Carbon 12 is the international standard which is used to measure relative atomic masses for all the elements. So carbon 12 is the international standard. Now, this question is about the relative atomic masses. So the relative mass of the isotope and percentage abundances are given. And this is the formula. A relative atomic mass is sum of relative masses into percentage abundance over total abundance. So the percentage abundances are given. The relative masses are also there. So 24 times 85 and 26 times 15 by total abundance is 100. So if you solve this, 2430 divided by 100, you will get 24.3, 1 decimal place answer. So relative atomic masses can be calculated by taking the sum of relative atomic masses with the relative abundances of the isotopes of different elements. Now, an ion contains 10 electrons, 13 protons, and 14 neutrons. So proton number is the identity of an element. This is the identity. So if you look at the periodic table, just check the proton number, and you will find that aluminium is the element which has the 13 proton number. So aluminium is the element, and it contains now 10 electrons, 13 protons, and 14 neutrons. State the nucleon number ion. Now the nucleon number is the sum of p plus n. So there are 13 protons and 14 neutrons. So if you add this number, you will get 27. So 27 is the nucleon number. Identify the element that forms this ion. As I have already mentioned, that 13 is the proton number of aluminium. So this element is aluminium. Next question. This question is about ionic compound. The structure of magnesium atom and fluorine atom are there. So this is the electronic configuration of magnesium 282. This is the electronic configuration of fluorine 27. This is in group 2. This is in group 7. You know that the elements which are present in the group 2, they can form 2 positive charge, and group 7 elements, they can form one negative charge. So one negative mean gain of one electron, two positive mean loss of two electrons. So if we remove these two electrons, we will get the structure of Mg2 positive, and if you add this one cross or one electron in fluorine, we will get the structure of F negative. So fluorine and magnesium. Magnesium is present in group 2, so that's why 2 positive charge. Fluorine is in group 7, so 1 negative. Now, first of all, copy the structure. Now, the electronic configuration of Mg was 282, and then 2,8, because the two electrons are lost by this Mg, and this is the final electronic configuration. You'll have to draw one magnesium ion and one fluoride ion. Now, the fluorine has 7 electrons in its outermost shell. A 7 electron. When it gains 1 electron, this is the electronic configuration of fluoride ion. Deduce the formula of magnesium fluoride. Mg having 2 positive charge, fluorine having 1 negative charge. So the formula of magnesium fluoride will be MgF2. Then, when solid magnesium fluoride is dissolved in water, it forms a solution that conducts electricity. State one other change that can be made to the solid magnesium fluoride to allow it to conduct electricity. Magnesium fluoride is a ionic compound, and ionic compound they can conduct electricity in two forms: in aqueous solutions and in molten. In these two conditions, they have the free ions which are responsible for the conductivity. So when you start melting this ionic compound, you can see that the molten magnesium fluoride can conduct electricity due to the presence of free ions. This is the dot and cross diagram for silicon um, silicon tetrachloride. So silicon tetrachloride, Si is in group 4. So it has 4 electrons in its outermost shell. 1, 2, 3, 4. Chlorine is in group 7. It has 7 electrons in its outermost shell. 1, then 2, 3, 4, 5, 6, 7. There are 4 chlorine. 1, 2, 3, 4, 5, 6, 7. Then again 1, and show the rest of the 3 pairs, although they are not taking part in the chemical bonding, but they are the part of chlorine. So you must show the complete octet. So this is the structure of silicon tetrachloride. Now you have the two compounds, silicon tetrachloride having melting point -69, silicon 4 oxide 1710. So silicon tetrachloride has a low melting point because it has weak forces of attraction between particles. Name the type of particles that are held together by these weak forces of attraction. Silicon tetrachloride is a simple covalent structure. It is a simple covalent structure, and silicon 4 oxide is a giant covalent structure. So simple covalent structures, they are bonded by the weak intermolecular forces, and the molecules are actually bonded through the weak intermolecular forces. So the type of particles that are held together by the weak forces of attraction or weak intermolecular forces, those are molecules. And explain the terms of structure and bonding, why silicon 4 oxide has a high melting point. Silicon 4 oxide, it is a giant covalent structure. It is a giant covalent structure. Strong covalent bond between oxygen and silicon and oxygen. So a lot of heat energy is required to break this bond. Is required to break these bonds because there are a lot of strong covalents. This question is regarding the reaction between zinc and sulfuric acid, uh, in which the lumps of zinc react with the dilute sulfuric acid to form hydrogen gas, and hydrogen gas can be collected in this gas range. So let us see what is happening in the questions. The rate of the reaction decreases as the reaction progresses, so the rate eventually becomes zero. Explain why the rate of the reaction decreases as the reaction progresses. Now, there are two reactants. If we look at the reactants, zinc and sulfuric acid, zinc is in excess. So zinc is not used. It remains at the end of the reaction. Sulfuric acid is the limiting reagent. So concentration of sulfuric acid decreases with respect to time, or you can say if the less amount of sulfuric acid is available, so the frequency of effective collision will also decrease. So concentration of sulfuric acid particles and decreases because zinc is in excess. Explain why the rate of the reaction eventually becomes zero. A time will come when there is no more sulfuric acid. So at that time, the reaction stops. So when all the sulfuric acid has been used up, there must be no reaction. All the sulfuric acid has used up, then there will be no reaction, and ultimately at that time, the reaction eventually becomes the rate of the reaction eventually becomes zero. The experiment is repeated using powder zinc instead of lumps of zinc, mean the large pieces of zinc. Explain the terms of Boolean theory, why the rate of the reaction increases if powder zinc is used. If you use the powder zinc, definitely the powder will provide us the greater surface area, and the frequency of Boolean will also increase. So it provides uh, larger or greater surface area. And if we have more surface area, the frequency of the collision between these two reactants will also increase. Frequency of collisions between zinc and sulfuric acid uh, particles increases. Okay, then this is the reaction of zinc and sulfuric acid, and this is the concentration of sulfuric acid, volume of sulfuric acid. Calculate the number of moles. Moles is C times V by 1000. Concentration is 2.00, volume is 25 divided by 1000, which is 0.05. Then moles of hydrogen. Compare the moles of sulfuric acid with moles of hydrogen. This is an excess. Sulfuric acid is a limiting reagent. As the molar ratio of these two reagents is same, so that's why 1 mole can produce 1 mole. So the number of moles of hydrogen are same as sulfuric acid. Calculate the volume of hydrogen gas. So volume is moles times, look at the unit, 24. So moles are 0.05 times 24, 1.2. So 1.2 dm cube hydrogen gas will be produced. Now, if we change the acid, zinc is there. If it reacts with the hydrochloric acid, zinc is there. If it reacts with the hydrochloric acid, you will get zinc chloride plus hydrogen gas, and this is the balanced equation. Then the hydrogen gas which is produced, test if you put a lighted splint. You can see that the hydrogen pop up in a lighted splint, or it can produce a squeaky pop. Now, this question is about electricity in chemical reactions. So, aqueous copper 2 sulfate is electrolyte, and it is electrolyzed by using inert electrodes. Copper at the cathode, oxygen at the anode. These are the two products. Cathode is a negative electrode, anode is a positive electrode. So, these are the two products of electrodes. Uh, State what is meant by the term Electrolyte. Electrolyte, it may be the ionic compound or aqueous solution of an acid. Ionic compound in molten, you can say molten, or in aqueous, or aqueous solution of acid, which can conduct electricity. Then the term this, what does it mean? This is the oxidation state. Mean copper 2 sulfate. Copper 2 sulfate mean the oxidation state of copper is 2 positive, sulfate is 2 negative. So that's why the formula is CuSO4. It doesn't mean that there are two copper. Copper 2 mean the oxidation state of copper is +2. State what happens to the color of the aqueous copper 2 sulfate as the electrolysis progresses. If you are doing the electrolysis of copper 2 sulfate by using two types of electrode, inert electrodes and copper electrodes. So in inert electrode, the blue color fades to colorless, blue color fades to colorless, and if you are using the copper electrodes, uh, it remains blue because copper ion are restored by dissolving copper. So blue solution turns to colorless or fades to colorless. Write an ionic equation for the formation of copper. Formation of copper means copper must be on the right hand side. Cu2 plus ions are required, and at cathode there is a reduction. Reduction at cathode. Reduction is the gain of electrons. So this is the ionic half equation for the formation of copper at copper cathode. Give the formula of the ion that form oxygen at the anode. Uh, this is the equation. OH negative, they will form water plus oxygen plus electron, or you will get only the oxygen because water becomes the part of this aqueous solution. So OH negative ions are responsible for the formation of oxygen at the anode. Now, the electrolysis of aqueous copper 2 sulfate is repeated using copper electrodes. State what happens to the anode. If you use the copper electrodes and you are doing the electrolysis of copper 2 sulfate, the anode dissolves. If you are using the silver nitrate and uh, silver electrode, the silver anode dissolves. Spoons can be electroplated with the silver. Name the substances used as the anode positive electrode. So the anode should be the article to be the metal to be deposited. So it's because we're doing the silver plating, silver is deposited. So anode must be the metal to be deposited. So it must be made up of metal to be deposited, silver. And the object or the article to be plated, it must be connected with the negative terminal of the battery. So spoon is the negative electrode or the cathode. Electrolyte should be the any soluble salt of anode. So if we are using anode as a silver as the anode, so you must use the aqueous solution of silver nitrate because any soluble salt of silver we can use. State two reasons why spoons are electroplated. Uh, this is a general question that if you want to enhance the beauty of the substance or if you wants to improve the appearance of the substance or article, okay, or to improve beauty, or we can say that if you want to prevent your article from the rusting, prevent corrosion or from rusting, we can use the process of electroplating. Now, this is hydrogen oxygen fuel cell. Still, one adverse effect of the carbon dioxide and carbon monoxide. Carbon monoxide, that causes global warming. And carbon monoxide is a toxic gas, or this is poisonous gas. Okay. Needs one disadvantage other than the cost of using hydrogen oxygen fuel cell to power cars compared to using petrol. There is a storage problem of hydrogen because high pressure is needed to store hydrogen. To store hydrogen. Okay, move to the next part. This is regarding Haber's process. State the source of the nitrogen. Nitrogen is obtained from the fractional distillation of liquid air. So air is the source of nitrogen. Hydrogen, it comes from the cracking of petroleum or by reacting methane with steam. So methane is the source of hydrogen, or petroleum is the source for hydrogen. Then there are certain conditions for the Haber process. Temperature must be 450 degrees Celsius and pressure 200 atmospheric pressure. And iron is the catalyst which is used in the Haber process. Catalyst, catalyst, a substance which speeds up the reaction without being used itself. A substance speeds up the reaction, speeds up the reaction rate or rate of reaction, and it remains unchanged at the end of reaction. Now, ammonia is converted into nitric acid. This is the equation in which the ammonia reacts with the oxygen to form nitrogen monoxide and water, and then there are further processes in which it is converted into nitric acid. Now, using explanations that do not involve cost, explain why the temperature less than 900 degrees Celsius is not used. This is the optimum temperature for this reaction. If we decrease the temperature, the rate of the reaction decreases. Rate of reaction decreases. So that's why we're not using the temperature less than 900 degrees Celsius. Explain why the pressure greater than 7 atmospheric pressure is not used. Is using the 7 atmospheric pressure. So if we increase the pressure, we can see that the 9 moles of gases are on the left hand side, 10 moles of gases are on the right hand side. So if we increase pressure, the equilibrium shifts to left, from more moles to left, and that will decrease the yield of your product. So that's why we're not using the higher pressure than this one, as the position of equilibrium shifts to left. Okay, and definitely the yield of the product will also decrease. Okay, now this is another question. Now you have nitrogen monoxide and then oxygen and then water. You have to balance this chemical equation. If you say that there are 2 hydrogen, if we put 2 here, it will make the nitrogen 2. So we have to put 2 here. Now hydrogen and nitrogen, they are balanced, but the number of oxygen atoms are not balanced. 6 oxygen on the right hand side, 2, 4, 5 on the left hand side. Okay, so definitely we'll have to increase the number of oxygen, 6 on the right hand side, 2, 4, 5 on the left hand side. So how can we increase the number of oxygen atom? If we say that if we say 3 by 2, okay, 3, 4, 5, 6, okay. Now 3 by 2, if we write 3 by 2 here, we will get the oxygen 6, but to remove this denominator, we'll have to multiply the whole equation by 2, So if you multiply with 2, it becomes 4. Then 2 here, then 3 by 2 times 2, 3, 3 here, and then 4 here. So these are the balancing coefficient for this chemical equation. Okay, now copper 2 nitrate by adding excess of copper 2 carbonate to the dilute nitric acid, symbol equation. This is the copper 2 carbonate, so this is copper 2 carbonate. If it reacts with the nitric acid, HNO3 is the nitric acid to get copper 2 nitrate. Okay, so this is the copper 2 nitrate. Metal carbonate reacts with the acid to form salt, water, and carbon dioxide. So this is the salt, and then water, and then carbon dioxide. So if you want to balance this chemical equation, just put 2 here, and this is the balanced chemical equation. State 2 observations that indicate the copper 2 carbonate is in excess. So this copper 2 carbonate, it is reacting with the nitric acid. If this copper 2 carbonate is in excess, a time will come when no more copper carbonate can be dissolved in nitric acid. So you can see the undissolved solid. So when you see the undissolved solid, you can see that there is no more reaction because the nitric acid is completely used up. And second observation is that copper carbonate can produce the effervescence of carbon dioxide. When there is no more effervescence, then it means no more reaction. The nitric acid is used up. So effervescence, when effervescence stops, on adding more copper carbonate, it means the copper carbonate is not reacting with the nitric acid. Name one compound other than the copper 2 carbonate that can be added to the dilute nitric acid to produce aqueous copper 2 nitrate. You can use the metal oxide, mean copper 2 hydroxide, or copper 2 oxide. So copper 2 hydroxide, copper 2 oxide, and copper 2 carbonate all react with the nitric acid to form copper 2 nitrate salt. Okay, this question is regarding organic chemistry, the reaction of propane with the chlorine to form different products. So state the conditions required for this reaction. This is a photochemical reaction, and it requires a ultraviolet light. It requires a UV light. And draw the displayed formula of the two structural isomers with the C3H7Cl. So you can change the position of chlorine. Okay, you can change the position of chlorine to get isomer. So there are 3 carbon. There are 3 carbon. Uh, in the first isomer, if the chlorine is on the first carbon, just make it on the second carbon. Now these are the two isotopes of C3H7Cl. The first one is 1-chloropropane, and the second one is 2-chloropropane. Carbon can make 4 covalent bond. Carbon is tetravalent. So you have to show the carbon as a tetravalent element. This is the 1-chloropropane because the chlorine is on first carbon. And this compound is 2-chloropropane. Okay. Now, alkenes are a homologous series of hydrocarbon. State 2 characteristics that members of the same homologous series have in common. Uh, the two consecutive members differ by CH2 group and 14 digits in their MR. They have the same general formula. They have the same functional group. They have the similar chemical properties, but there is a gradual change in their physical properties. So the two characteristics that the members of the same homologous series have in common, they may have their same functional group. As you can see in the above compounds, the chlorine is the functional group. So same functional group. Then they have their similar chemical properties. Okay. Then Addition polymers are made from alkenes. Show one repeat unit for addition polymer. Butene. Okay. First of all, this is the butene. This is butene. This is the monomer. So if you want to make the polymer, just extend this group. Okay, so this carbon is attached with hydrogen and CH3. So here we can make hydrogen and CH3, hydrogen and CH3, and there's a single covalent bond. So this is the repeat unit of butene. Now the repeat unit of the condensation polymer. This is a condensation polymer, and if you want to deduce the two monomers, draw the structures of the monomers used to produce this polymer. Just look at this. This is the ester linkage. So if you break your compound from here, okay, and if you put hydrogen here, this is the first monomer, and if you put OH with both these groups, this is the second monomer. So you can copy CH2, C double bond O, C double bond O, and then this extension was there, and then CH2, then CH2, and then O was there. So just add H group with this to make it alcohol, and OH with this to make it dicarboxylic acid. So these are the two monomers for this condensation polymer. I name the type of condensation polymer in figure 7.2. Now this is the polyester because it contains many ester linkage. So whenever the alcohol and carboxylic acid, they will react, will get the ester. Name two homologous series to which the monomer in one belong. One is from carboxylic acid and the other is from alcohol. So one is from carboxylic acid and other is from alcohol. As you can see, this is the carboxylic acid group and this is the alcohol. This is the alcohol and this is the carboxylic acid group. So one monomer is from carboxylic acid and one is from alcohol. So this is all about this paper. Thank you.